And we'll start our first talk for today by Jovonni, the Blockchain Director of Corium, and he will be giving a pitch about the next generation of blockchain assets, smart tokens use cases. Please give him a warm round of applause.
So my name is Jovonni. I am the Blockchain Director for Corium. Kind of a little bit about me, so I've kind of been in the space for a while. So I've been an engineer for about 15 years, full stack mainly. In 2015, this is when I worked for a large insurance agent or a large insurance company in America called State Farm. And I was one of the lead engineers in research and development. And so one of the first projects that they put me on, they literally put a red folder on my desk with Satoshi Nakamoto's paper in it. And so they said, hey, figure out what this thing is, figure out how we could build our own, good luck, and then also figure out how we can build on top of it. And I had no idea what Bitcoin was at the time, and this was in 2015. So that started my venture into this entire field, right? And I've never reemerged from this passion. But so I did that for a while, built some cool stuff on top of it, integrated a bunch of different chains at the time. And I also spent some time looking deeper into Ethereum and what its issues were. So then I spent a few years building some open source tools that were, this was pre-Substrate and pre-Cosmos, where I was pretty much building layer 0 tools to generate layer 1s, which is a whole talk by itself. But after that, I ended up working with Certic as well, where I did a bunch of MEV stuff, kind of like real-time MEV analysis, which also started like my hobbyistic career as an MEV searcher. And I helped them do, like some auditing related stuff and helping them with different type of real-time systems to monitor on-chain data. After that, I ended up working with another entity called Dapper Labs, where I pretty much helped them upgrade their core protocol from V1 to V2. So been in the space for a while, and I'll never leave this space as long as it exists. So, but now I'm with Corium, and I think that we're working on some really interesting stuff, and hopefully you find them interesting. So today we're going to talk about what are smart tokens and what are some potential use cases that you kind of can use out the box with Corium. Okay, so first everybody in this room knows this kind of story, but let's talk about a little bit what are some key factors of the evolution of this blockchain space. And let's talk about generations of change, right? So obviously you have this granddaddy era, right, where Bitcoin comes out, everyone starts cloning this thing, right? Filecoin, this concept of color coins, right? You have all of these different coins that come out, and when you look at the actual repos, right, you notice that 97% of the code is Satoshi's code, right? But the key thing here is that, you have this layer 1 that obviously can't talk to anything. It's very purpose-built, right? So you have even like its transaction type, right, UTXOs, is very purpose-built. And, people have done things where they're storing stuff on Bitcoin, right, like using a no-op and storing data after it. But ultimately, this first generation is kind of like, it forces people to reuse its actual code because you can't really build on top of it unless you have like a real background in like replicated state machines at the time. So, and obviously what comes after that was the Ethereum era, right? And mind you, Ethereum didn't create this concept of smart contracts, right? Nick Szabo wrote about that way before Ethereum. But Ethereum, we say that it was one of the first real implementations of how you use smart contracts. But the most important part of this is you have this global state machine, this replicated state machine, where now everything's being stored on it, but you don't have to worry about cloning a L1. Now you're building on the application layer on top of it, right? But this now, at this point, has made the smart contracts become like a convention. Because when you think about it, all of these chains that allow for general purpose use or general purpose applications, they tend to have this common denominator of these smart contracts. But what's interesting to note here is that, if you think back to CryptoKitties and what Dapper Labs did, they pretty much almost broke Ethereum because they choked it with one application, right? And that's a core issue when you're talking about a replicated state machine or some global computer, as they say, right? If everything is going on top of it, and actually Gavin Wood talks about this, these general purpose chains are really good for prototyping, but once you know the logic of your application, purpose-built chains are really where you want to go. And I think CryptoKitties is really who demonstrated that first. And if you look at now what Dapper Labs is doing, they have their own chain, right, own language, but they built it with the problems. They built it to counteract the problems that they ran into, which is actually pretty smart. So then this third generation, you have now these, and I should actually say Cosmos SDK, by the way, but you have this fundamental layer 0 tools now that people use to then generate layer 1s. The interesting thing about this is with this generation, you start to see people use these layer 0 tools to generate both purpose-built blockchains that have just one single purpose and multi-purpose blockchains. And I think that that's so interesting to keep in mind because who knows what generation 4 looks like, but if you look at the leap from generation 1, Bitcoin, to Ethereum, it's this big. If you look at the leap from the Ethereum era to these layer 0s, it's a large leap, right? So it will be interesting to fantasize about what generation 4 looks like, right? So I think that the future is going to be interesting there. But now, based on that history, let's talk about these implementations of these, and I assume everybody in here knows what these two ERC specs are, right? NFTs and fungible tokens. If you look at the graph on the left, this is showing you the amount of implementations of ERC20s over time. And it's only up to 2020, so forgive me. The yellow there is pure vanilla implementations of ERC20s. Do you know what I mean when I say vanilla? Okay, everybody, okay. For those who don't know, vanilla is you take the spec of an ERC20 and exactly that's what you implement, nothing extra. If you look at the green though, those are ERC20s that have additional functionality in it, right? But pay attention to the distribution. The majority of these implementations on the left are vanilla basic ERC20s. On the right side is the same type of story for the NFT specs, where if you see, and the distribution is actually more skewed heavily towards vanilla. The light purple on the right side are vanilla ERC721 implementations. And you have some other specs, 1155, which is the multi-minting, right, NFTs. But the story being told here is that, and I don't know the motive, right? It could be the case that developers don't know they need to have extra functionality. It's either the case that they don't want extra functionality or maybe something else. But the point, though, is that majority of implementations of both of these very core asset types are vanilla implementations. That's the takeaway here. So just 2 points here. For each contract, it's an isolated implementation, right? That's by design, of course. And the bottom here is you have this human error aspect where now you must rely on yourself to implement these standards right. And you have some help doing that, right? It's not like you have to do it from scratch every time. So how many people in here are familiar with OpenZeppelin? Right, many of us, okay, from the EVM world, right? For those who don't know, OpenZeppelin, their entity, one of their public goods that they offer to the world is they give you these implementations of these assets so that you can then copy and paste it and not have to worry about any potential exploit, or at least worry about it less, someone exploiting your code or you implementing something incorrectly. However, one thing about that is, let's take 721, for example. You have many different flavors of ERC 721 implementations, right? You have burnable 721s, enumerable, right? Mintable, right? You just have many implementations, and it's built on the same spec, that core spec, but there's added functionality, right? Sometimes you may have an implementation of 721s that now they're implementing the safe math library in EVM, right? But the problem with that is, even though OpenZeppelin is giving you the contract for you to copy and paste, you as a developer have to choose the right one, and then you have to hope that it wasn't upgraded and you don't have an older version, right? And it's not difficult, but it still requires mental thought on the developer side. And the longer you've done it, it's actually easier, but I have seen many projects either get hacked or there's some bug that's taken advantage of mistakenly, simply because they have an older version of what they should have. or they're not using safe math, or something like that. And so this human error is something that's important to note here. But when you have someone giving you specs, some measurable metrics, it increases reusability, right, obviously. It decreases security concern, ideally, I should stress, and it increases development speed, ideally, right, and which is good. So this brings us to what are smart tokens? So the original idea of a smart token, very, very simply, was could you wrap smart contract logic around native tokens? And if you think about it, every chain by convention has its own native token, right? Ethereum has ETH, but you can't really program ETH, and maybe you don't want to, right? But that was the original concept before we actually started down this path. In terms of implementation, what we've done are the following. So we treat NFTs and fungible tokens as first-class citizens in Corium. What does that mean? That means that whenever you implement a 721 or ERC20 on Corium, it automatically inherits built-in logic that we built into the actual protocol. So this means that you don't have to worry about actually implementing this boilerplate code, and you can rely on it being audited and working the way that you need it to work. The good thing about it, though, which this smart word starts to come into play, is that now, because you can write contracts in CosmWasm, you can extend that basic functionality that we provide to you. And also, with our smart tokens, we have features for each asset type that you can just enable. So for example, if you're using a fungible token, you can enable mintability, you can enable burnability, right? You can enable freezability, you can enable whitelisting, you can enable blacklisting, but you don't have to write that code yourself. And so the point here is to allow developers to move faster, whether they're building on our chain fundamentally or bridging to our chain via some methodology. The point is you can now implement the same type of asset types, and we go back to the distribution, majority is vanilla. You can implement that same logic without having to actually write it yourself and worry about the implementation details. And we'll see what that allows you to do out the box. So here's a few points, right? I said smart tokens implement fundamental asset logic that we've built into the protocol. I also mentioned that developers can choose to extend this foundational logic, and both asset types are treated as first-class citizens. So here's some of the features that are built into these asset types. So we have permission minting, you have minting quotas and limits, you have time-based minting, right, restrictions, and typically that's usually done like referencing a block height or in a less secure way, referencing a timestamp, right? You have role-based access control that's actually built into these asset types. And for the record as well, for the devs in the room, we're doing a workshop later today, and we're gonna be showing you step-by-step how to build these smart tokens using our SDK and also using our CLI. So I think that today is like at 3 o'clock or something. But you also have multi-sig approvals, minting conditions and triggers, auditability and transparency. And auditability and transparency really comes from the fact that our core implementations are audited by external entities. And obviously, it's in our protocol. So when you implement these asset types, you're getting that out the box. And the last part here is just customization and upgradability, right? But the point is, using these features, you can now create some really interesting and fairly complex applications out of the box without having to implement the logic yourself. So if you already have all of your smart contracts written, then you might have one use for this, but at the end of the day, if you're in the middle of building and you're actually writing that logic yourself, it's worth considering what the trade-offs will be when you kind of abstract that responsibility from your dev team. So obviously, we're built on Cosmos SDK, and so here are some fundamental additions we've built on top of that. So the first thing that we built is this fee model module. The fee model is primarily responsible for us calculating the minimum gas price. And so obviously everyone in here knows, but let's say if you deployed a smart contract on some chain and you called it every day of the year with the same exact logic, what's gonna happen to your gas price? it's going to be doing this, right? Based on the economics of the chain and activity on the chain. So what we did, and typically if you think about it, there's usually a linear relationship between the economic activity on a chain and gas price, meaning that typically there's a linear relationship between how much activity is happening and how much you're paying in gas price for all of your, for your total transaction execution. So what we did is we built a nonlinear model. So on one side of the extreme, you have no economic activity. And at that point, what we're doing is using a power function, we're decreasing gas price to a maximum discount that we can offer. And for the optimal usage on the chain, we're offering maximum discount. And then if the chain starts to become stressed and many transactions, then you can increase gas price, how you typically see on chains anyways, right? But this non-linearity, though, allows us to more so guarantee maximum discounts for gas price. The second module there I kind of talked about already, which is these asset types. The third thing there is super important, though, because this deterministic gas module allows us to, for common known transactions, excluding complex transactions, what we can do is now we can simply do a lookup to use a predetermined gas price, a predetermined gas amount for certain transactions. So typically, like if you use an Ethereum, when you do a send, right, there's a fixed amount of gas that you're paying for that always, right? But that's mainly for those type of transactions. But what we did is we widened that scope, and we're taking many different known transaction types, and we're now making it where the gas is extremely deterministic and static. So let me go through some of these use cases really quick. So this is just artwork collection, right? And if you just take advantage of the time-regulated minting, and just using the NFT asset type out of the box, you can now implement a fully functional NFT collection that's time-based out of the box. Seasonal financial products, right? This again is, and what I'm showing here in these first 3 slides is the same exact features of these asset types, and composing them together, you can create 3 or 4 wildly different applications. So here we're just using specific issuance periods of these tokens, which is time-based minting. And if you did that right, just using fungible tokens, now you can create time-relative minting of your tokens out of the box. Same thing with tokenized rewards. Right here, it's the same thing. We're just using time-based minting for another use case. And for each of these 3, we're assuming that your application layer is exactly what you want it to be, because that's what's going to differentiate the application in the end, not this core logic. Here with crowdfunding campaigns, right, this is just using fungible tokens out of the box, and fungible tokens representing ownership in the actual project. And then using the predefined conditions that we talked about earlier, you can now make it where, if a project doesn't reach its fundraising goal, then it doesn't get the tokens, and then people can withdraw their tokens, et cetera, if they're locked in a contract. Super basic. This is more NFT stuff, right? Again, we're taking time-based minting and minting based on special conditions right out the box, as long as your application layer does it right. Right, this is just right out the box. Don't have to worry about implementation details like that. Here are event tickets, right? There's no bolds on here, so the key thing here is that you're having different NFTs for different ticket types, right? And if you add time-based minting to those, we have like a purchase window, you get that out the box. Same thing with utility tokens, right? Imagine having a utility token, and out of the box, you can issue these tokens based on your roadmap and based on like people voting if your roadmap is completed, your milestones, right? If you did this right and your application layer is written right, this is right out the box. This is real estate investment trust. This is a whole talk by itself, right? But this is pretty much minting new tokens based on the performance of the actual like financial instrument. And it's also taken into account time-based minting as well. This is loyalty points programs, where here you're having people minting tokens based on how many tokens they need to hold will represent like what their membership tier is pretty much. But the point here is time-based minting, and you have like conditional minting, right? Just right out the box, as long as your application layer is doing what it's supposed to do. So here, and I'm almost done with the use cases here, here's time-based minting and limited time during the event is when you're printing these NFTs or minting these NFTs. Just combining those two features, you can get this right out the box as long as your application layer is working right. This is the same thing. This is just tokenized employee incentive program. Imagine being an employee and you get an NFT because you did something great, and then now the NFT gives you some perks right down the road. This is just royalty-based IP licensing, pretty straightforward, but the royalty, you can have that built in if you did that right. This subscription service using access control lists, which we'll show you later on today in the workshop. Here's some works in progress. We're doing a bunch of IBC work, and we're doing a bunch of native DEX work. I think we could talk about that all day. I'm kind of running out of time here. But we're also partnering with a company that's helping us build another DEX on top of Corium. And here's the last slide, calling all developers in the room. If you have any interesting project, we have a very interesting grant program, and we just wrapped up our Grant Wave 2. A little bit of alpha for you. We're about to release our Grant Wave 3. So please apply, and we'll be working with me directly, so if you're interested. And for my auditors in the room, we have a bug bounty that we just launched, and we're working with Certic directly. And so if you're interested, it's a $25,000 bounty. You have to submit it through Certic, but it's open to the public, so that's another alpha. So if you're interested in either of these, please come talk to me during the day or go to corium.com. You'll see information on it. And thank you for paying attention. I appreciate you guys.